See the polymerization process beginning to work its magic as the cyanoacrylate vapours come into contact with the moisture now present in the latent fingerprints. At a molecular level, we're witnessing small molecules, which are called monomers, join together to form long chains called polymers. These solid white coloured polymers are building up along the ridges of the latent finger marks, making them visible and providing some contrast against the background. Well, this all really relates to what's going on at the molecular level. We know that when we deposit latent finger marks, we leave behind residues that include certain salts, things like sodium chloride. Now, these salts actually dissolve at a certain relative humidity. That's called its deliquescence point, and that's known to be about 78 to 79%. And we know that the polymerization of cyanoacrylate monomers actually occurs in the presence of moisture or water. So if we can get that moisture into the latent finger marks via these salts, then we can initiate that polymerization preferentially along the fingerprint ridges. That's why we require and we target a relative humidity of approximately 80%. And that's why we need absolute control of these parameters all around the confines of the MVC or the cyanoacrylate fuming cabinet that is being used. So whilst cyanoacrylate fuming is a time-proven and highly effective technique, the results can often be difficult to visualize. And this is primarily because the polymer residue is white and it can sometimes be quite faint in appearance. So in some cases, depending on the surface you're examining, it may not be possible to observe as much ridge detail and photograph the fingerprints in a suitable manner. Fortunately, with cyanoacrylate fuming being such a widely used technique, there are a lot of options for us to explore when it comes to further increasing finger mark visibility and contrast. What we're effectively talking about here is sequential treatments, the process of layering up multiple enhancement techniques as we try to reveal an identifiable fingerprint. In the case of a cyanoacrylate fume fingerprint, we have lots of options available to us. Liquid dyes and dusting powders are both widely used in sequence with cyanoacrylate. But before we apply any further chemical treatments to our piece of evidence, I'm going to start by employing a non-contact, non-destructive method of visualization in the form of the highly effective but widely misunderstood technique of reflective long-wave ultraviolet imaging.